Hi there, let's check out what's waiting for us in the upcoming Python 3.14 release. So the release schedule first. Beta 1 is planned for beginning of this May, then there will be no more new features in this release, only bug fixes and minor changes. When there are going to be 3 more beta releases, then 2 more release candidates, and the final release is planned for October. Okay, let's see what new features are. So first change is accepted PEPs 765, disallow return, break, continue that exists of finally block. Check out this example. Here we have 2 return statements, one in the try block and another in the finally block. This could be confusing, but this function will return 2 and not 1, because finally is executing last, always, no exceptions. So here is kind of obvious as long as you know that, but check out this example. Now we're raising an exception in the try block, but it will not matter here. As you know, finally is always executed last, so this function will return 2 as well, as well as an exception. Probably not what we expect. Okay, and last example. Here we're running a loop, and inside we are simply returning from the function, but with a catch. In the finally block, there is a continue statement that makes this loop run forever instead of finishing after the first iteration. So from 3.14, Python will emit syntax warning for such cases. And in the future, it will be a syntax error, and we will not be able to write such confusing code again. So next change is PEP 648, deferred evaluation of annotations, which is going to make annotations better. Previously, in the code like this, you would get an error on the first line, even if without annotations, it's perfectly working code. This was because Python was evaluating annotations at the time it made them, and we had to define every type before we use it. As a hacky workaround for this, before 3.14, we could use strings in annotations and then evaluate them later when we need it. But now in 3.14, we just can use forward references, and Python will postpone the evaluation of annotations until they are used. It would even allow us to use reference types we don't have defined anywhere, and it will still not result in a runtime error. And another little syntax change. PEP 765 allow accept and accept star expressions without parentheses. Before 3.14, in a code like this example, in except blocks, if we wanted to list multiple exception types, we had to use parentheses. Starting from Python 3.14, we now can omit parentheses and it will work just fine. And in case we want to capture the exception instance with s keyword, we still need to use parentheses like this. Okay, and now my favorite topic. There are going to be a lot of performance improvements. First one is a new type of interpreter called tail call interpreter, making Python up to 13% faster. Do not confuse it with tail call optimization for Python functions. And we will talk about the interpreter again soon. So when there are a bunch of improvements or work in progress features like JIT optimizer, free trading Python called NOGIL. Also, Async.io got like 10% overall boost according to PyPerformance benchmark. Then in the I/O module, there is about 15% speed up on opening and reading small files due to reduced number of system calls. In the same model, default buffer size constant value is increased from 8 to 128 kilobytes, and this could give us around 3 to 5 times speed up, at least on Windows. Another Windows improvement, there is computed GoTo optimization enabled for supported compilers. For compression, zlib default compression level is lowered from 9 to 6, improving performance by around 70% in cost of compression ratio. And again for Windows, now zlib-ng is used as an implementation, and this is increasing performance by another 80%. Lastly, there are improvements in base64 decoding and importing, which are 10 and 6 times faster respectively. And in UUID functions, these UUID 3, 4, 5, 8, they're faster by 20 to 40%. Okay, and now let's talk about this new tail call interpreter. Let me explain a bit how the interpreter works itself. Yeah, and then I say the interpreter, I mean CPython. Okay, so when you run a Python script, the interpreter takes your source code and breaks it into tokens, small pieces of code like words in a sentence. When it builds a tree of these tokens called abstract syntax tree or AST, containing all the structure information. Then it takes this tree and compiles it into a form suitable for execution called bytecode. Then this bytecode could be optimized, but it doesn't matter for us since in the end it gets finally executed by Python and they can see the result. So this last step, execution, is the most important and usually it's one that affects performance the most. And let me show how this works in Python-like pseudocode. Here we have a function executed in bytecode. In the loop, it takes the next instruction, its opcode and arguments. Then, in a big case-like statement, it matches and executes the corresponding operation. And this approach with a lot of branches is pretty slow. To improve this, matching opcodes could be better with a perfect hash table. Here we will use a plain dictionary for simplicity, but in case of CPython, it's a static array. So now we can get a corresponding function by simple table lookup. This is how it works in current Python interpreter implementation, and in 3.14 it's going to be even faster. Notice that now we will have to make a call to a function and then back from it into the loop, and call to another function, back from it, call to another function, etc. And this is where tail call optimization comes in. Now, instead of looping over instructions, we can just call the first function and let the function itself handle going to the next one. Obviously, we now should change how our mini execute functions work. Let's check it with a single example. Before the tail call interpreter, it works like this. And now, in addition to args, it should accept a reference to the whole bytecode and a pointer to the current instruction. Then, after doing its actual job, it should get the next instruction and make a call to it itself, like this. Since this call happens at the end of the function, it's called tail call, and this tail call usually can be optimized by modern compilers. So there is no actual call and no creation of new stack frame, no possible stack overflow, and this is very fast. So in current implementation, we don't have a loop, and in compiled code, we don't have functions either. And this is why it's faster this way, and it's how it's going to work in Python 3.14. Okay, I hope it was interesting. Now, since we're talking about the interpreter, let's talk about the common interpretation technique called JIT compiler. And note that most likely we are not going to get it in 3.14. It's still experimental, but it's got a lot of improvements in this release. Okay, so JIT, or just-in-time, is a compilation technique where instead of executing bytecode instruction by instruction, we compiled it, at least part of it, into machine code, and then let CPU execute it efficiently. Remember our interpreter graph? So now, after we have our bytecode, let's call it tier 1 bytecode. We're going first compile it into intermediate representation, called tier 2 bytecode. We need separate representation because it could be made more suitable for later steps, since tier 1 bytecode was made solely for execution, and we don't want to change it a lot. So after we get our IR, we can now optimize it, probably in several steps, and then compile it into the machine code and execute the result. And now this is how Python's JIT compiler works. Currently, optimizations are pretty simple and made using the copy and patch technique. And because of that, performance is not that great. Running the PyPerformance benchmark on my machine, I have got that 25 tests that sound that faster, 20 was somewhat slower, and on average improvement is about 2%. Sounds not much, but it's a step in the right direction. It opens a lot of possibilities for performance improvements, and in the future we could expect to be better and better from each release. Okay, and last one performance improvement I will explain in depth. So we were talking about how the interpreter executes the bytecode instructions with the following simplified pseudocode example. Since Python can be executed in multiple threads, we have to make sure when we run our bytecode instructions, our internal state is not affected by data races. And the simplest way to be sure is to just log here. And this is implementation used by current CPython. This log in Python is called GIL, or Global Interpreter Log, and basically it's preventing multiple threads from executing Python bytecode at once. And this is what makes Python threads a bad choice for CPU-hungry tasks. Traditionally, to avoid GIL, we had to either use C extensions or use multiprocessing model instead. This way we will have separate Python processes and they will each have their own GIL. But using multiple processes brings its own problems and makes communication between processes harder, and it's less CPU and memory efficient. So that's why free threading Python is a project which aims to remove GIL from the execution loop. This way, instruction execution should be thread safe, therefore more complex. And this will break binary compatibility with C extensions. So this is a big change and there is a lot of work to be done. But even if it's experimental, I have already checked its performance and that's what I've got. In the PyPerformance benchmark, in 8 tests, NOGIL was faster. In some tests, even like 2 to 4 times faster. but in most of the tests and on average, it was significantly slower. So again, there is a lot of work to be done, and probably we have to wait for another couple releases. Okay, we finished with performance improvements. Next patch, there are two more accepted PEPs I should mention. First one is PEP 741 Python Configuration C API, adding two new functions to Python C API, PyConfig_get and PyConfig_set, making configuration of Python more flexible. And second PEP is 762, deprecating PGP signatures of CPython artifacts. This PEP deprecates PGP signatures used to verify CPython artifacts in favor of Sigstore, the modern sign-in and verification system. I recommend you to check it out. Okay, now let's highlight some minor changes. So map function got a strict argument, like the zip to not silently ignore extra values. Memory view built-in type is now subscriptable, so it's generic. There is a new interpreter pool executor class, allowing to run functions in multiple subinterpreters. Path from pathlib got new methods with copy, copy into, move, and move into. Standard testing library, unit test, now produce colorful output by default. Built-in HTTP server now use a dark theme if the user browser asks for it. The JSON model can now be used as a tool to validate and print JSON, just like JQ2. And even more changes. If you forget to close the zip file, it will now emit a resource warning on deletion. Pickle got its default protocol upped from 4 to 5. Fraction and decimal numbers got a new construction method, from number. The Unicode database was updated to version 16.00. Many new MIT types were added, and finally, in the UUID model, support for UUID version 6, 7, and 8 was added. Okay, and as for summary, as of April 9th, changes in numbers are 1,716 commits by 646 authors, 2,135 files changed, 176k insertions, 259k deletions, at least 400 bug fixes, 67 new functions, classes, and methods, 29 performance improvements, 30 deprecated features, and 68 removals of previously deprecated features. Okay, and that's all for today. I hope you found this video useful and learned something new. Subscribe to get more content like this, and I will see you in the next one.